which is a hardening script that right now can help secure a system, help secure a Red Hat or Mandrake system. I say help, of course, because securing a system is never quite done. I'm also working with MandrakeSoft on all manners of things, so throw me an email and biodistribution and all kinds of things. Okay, so we're going to talk today about running secure DNS servers, and I'll basically go over right now what we're going to cover here. First, I've got a few slides just on installing and configuring the Unix bind server, just because this will really help when you go to try to chroot. We're going to try to simulate attacks, and we define attacks rather broadly as both attacks against the server and information probes that are unwanted. We're going to talk about what you can do about those attacks, so we're just very much attack and defense style. We'll get into chrooting daemons, chrooting the chrooting named running as a non-root user. We'll look at split horizon briefly. And I say briefly because we've only got an hour and you could do split horizon in 8. And we'll talk a little bit about DJBDNS. Okay, and we'll try to do questions at that point if we've got time left over. So let's get moving. This talk, by the way, is intended to be interactive. If you get bored, let me know. If you get completely snowed, also let me know, because we can slow down, speed up, and do all kinds of things to try to bring everybody up to speed. Okay, so a couple introductory remarks. What's DNS do? I promise we won't stay this basic, but let's just talk a little bit about what DNS is and how it works in general. Okay, so DNS is just there to provide a mapping between machine names and IP addresses. Okay, when I type www.slashdot.org into my browser, machines don't understand that. They get IP addresses, so there's this extra service on the internet called DNS that makes some translation of slashdot.org to slashdot's IP address so I can route packets there. Okay. Originally, back in the day, before I was on the internet, of course, they just had a big etc hosts file. They just had a big listing of host names and IP addresses. This had some serious problems because after a while, you could definitely get out of date. It would take you, it could take you a week to get on the internet because it could take you a week to get into that file. So you've got your web server ready to go, but now you've got to wait a week for that file to get updated, for everyone to get a fresh copy. And it is definitely not fault tolerant, which is kind of crazy because the internet's supposed to be massively fault tolerant. So this was replaced by something that was a whole lot more distributed, called domain name service. Okay. And basically, the way it works is instead of querying some central server and asking for an etc hosts file, what we end up doing is trying to find out who's got the information that we want. Okay, you want to know about, say you want to know about one of the machines in the math department at College Park, University of Maryland, College Park. Well, you can ask those central servers, hey, who's responsible for College Park? Okay, for University of Maryland. And they'll tell you, go talk to a name server at University of Maryland, and that machine will say, oh yeah, I know about University of Maryland, but we've delegated all of the stuff about the math department specifically to this other machine, so go talk to it. So you can talk to that other machine, and then you can ask, hey, can you give me the address for something in the math department? And this sounds mildly convoluted, but the idea is that I can distribute the administration of the system and also the points of failure across the entire internet. So you give as I think we all have gotten used to, you don't really have to worry about, DNS being totally fried for any long length of time, or any one DNS server somewhere taking down a large part of the internet. We can talk about how you would take down DNS. It's pretty doable. Okay, so basically, again, a couple more introductory slides, I promise, and then we'll get on to some of the good stuff. Basically, you have, when you have a name server, a machine that goes and makes these translations from names to IPs, most of them, we say most, but most of them have some information they're actually responsible for. Okay, it might be University of Maryland, it might be It might also, it might be University of Maryland, it might be University of Maryland and their reverse IP addresses. Name servers tend to mostly all have some part of the DNS space they're responsible for. Whenever you have to make a query, you have to talk to somebody first. You talk to root servers, okay? And I'll kind of try to explain how this works. In essence, you are, in this is a diagram we'll come back to here and there, but in essence, when you make when you want to know about /.org, okay, your machine, your client machine is configured to go and has a resolver on it. A resolver is generally a library or a program linked against that library. And that resolver is going to go and talk to your ISP's DNS server. Your ISP's DNS server is whatever DNS server you've told it, but often you get this from your ISP or you've set up one of your own, depending on how enterprising you are and how much of a headache you want to have. So basically, your resolver goes and makes a query against your ISP's DNS server. Okay, that DNS server can consult 3 different sources of information. First thing it'll do is see if it's already got an answer to whatever you're asking. Either if it's already responsible for the data you're asking about. In other words, if you're talking to the University of Maryland's web DNS server, are you asking about something at the University of Maryland? If you are, I got that in a file. I'll give you the info you need. If you're not, before it goes through a whole lot of work to get /.org or whatever name you're looking for, it checks and sees if it's done that in the past, say, day. And if it has, it's kept a cache. And then if none of that is appropriate, okay, I've got a mouse pointer here. What it's going to do is talk to the root servers. It's going to find out, okay, if we're looking for, say, something at math.umd.edu, okay, it's going to go and talk to the root servers. It's going to find out who's responsible for umd.edu. The machine responsible for umd.edu is, actually it's called Trantor, but we're going to call it ns.umd.edu, okay? And from there it's going to say, okay, do you have information on this machine in the math department? And that thing's going to say, no, I don't maintain the database for the math department. You got to talk to ns.math.umd.edu. And then you go and ask it, do you have the IP address for this one machine I want? And it says, yeah, here it is. Okay, I don't know if everybody remembers university, but this is actually exactly what happens at a university when you're trying to get your financial aid. You know, you get passed across campus, and it's never go over that desk over there. It's always across campus. And in DNS, this is, you know, in the university, it's kind of a good thing because, well, they think it's a good thing because maybe fewer people get financial aid because some of them just drop from exhaustion walking back and forth across campus. Okay, in DNS, this is a good thing because if one name server fails, we're not all screwed. Second, it's a good thing because it means that the math department doesn't have to wait on central university administration to update their list of names and IP addresses. They can do it themselves. So that distribution is a good thing. Okay, so that concludes our introductory material on what DNS was. Did I lose anybody? Raise a hand. Okay, cool. What I've given you to start is basically just instructions on how to compile bind date. This is really fun stuff. Yeah. Go to isc.org, download the source tarball, and use these commands to untar it, and you'll have to change one make file, and you're just going to have to change one thing, and that's to set 2 variables to the existing file. This is really simple. The file you download is not changed in years. It's not changing anytime soon. You just have to add these 2 things to the file because it makes sure that the entirety of your build happens in user local or gets placed in user local. What you get in the end is this big long make file that I've quoted here. And this is mostly just for your use when you go home because this makes it a whole lot easier. Instead of having to spend 3 hours getting this compiled and chrooting it, you can just kind of follow the instructions we've got. Okay. Once you've got that make file, it's just make depend, make install. Fairly similar to what you're used to. It would be nice if they auto-comped it, but they didn't for bind date. Okay. On Linux, this can be a lot easier, right? You know, you just go to find out the site where your distribution stores all their RPMs and download the right one. Okay. When these slides were written, the right one, or when this particular set of slides in the talk was written, the right one was 822P7. Where are we now, guys? Anybody know? What's that? Where are we in the 8 series? I know there's a 9 series, but where are we in the 8 series? 823P, no? 824. Okay, so we're not clear on this. Hit ISC's site, I'll tell you the most recent one. The thing is, whatever number you had this morning, 6 hours later there's been another bind patch because the darn thing's broken again. So just go get the most recent one. Now, to configure bind, there are some people in the room who are still using bind 4. We've basically written this towards bind 8, but the techniques here carry over to bind 4. They also carry over transparently to bind 9. But if you're still using bind 4, we've got this named.conf file we're using now, and I've included a sample. If you look at it, they were kind of they were trying to make the configuration file look like C, so it's a little more obvious what applied to what zones. And I've just given you an example, and we're going to add a whole lot to this example as we go. Okay, it's not important to understand all the pieces of it right now. I just want to show you an example so I can add to it. Okay. Before we get on to attacking DNS servers, I want to give you guys just a little bit in terms of bind date. Most people don't take advantage of logging. Logging is one of the 2 very boring but essential areas of security. The other one is patching. You know, patching and logging, very, very boring, but when you find yourself getting rooted, you really wish that you had either patched or that you had good logs so you could figure out what the heck had happened to your machines. What I've done is I've given you a cheat sheet. I'm going to give you a cheat sheet that tells you how to set up your logging so you don't have to read about it, and you can just get really great logs for security incidents. Okay, the way this basically works is bind 8 and bind 9 define something called a channel, which is a method of spitting a log out to something meaningful. Okay, and it's got a category, which is a specific type of data to pump along that channel. Okay, standard is kind of you've got a channel which is your normal syslog, and you've got a category which is all the categories, and you just spit everything to syslog and wade through when something goes wrong. But you can make this a lot more refined. To look at channels, what we're all used to is the channel, what I'm calling info syslog. You can call it whatever you want, but basically everything goes to syslog, and it goes out as daemon.info. You can change that. You can make it go out as mail.warning. Daemon.info seems like a pretty good one to start with. You can spit out logs to a file. You can spit out logs to console, to standard error. And you can also just spit out your logs to the bit bucket, and trust me, there's a bunch of bind channels that you just want to go to the bit bucket because it's a bunch of stuff that's, unless you've read some of the bind source code, doesn't make a whole lot of sense. So what I've given you is basically a list of some of the bind channels that are really useful. Okay, CNAME is all the CNAME errors. If you see CNAME, if you see stuff coming out of the CNAME channel, it just means, gee, this is stuff where one of your zone databases is probably corrupt. Sometimes it can be a security problem, so again, read your logs. Lame servers is a pain in the butt. And I've got 3 pages of logging channels. The best way to learn about each of these is to look at the DNS and bind book, or some of the documentation will go over what goes in each channel. Okay, so here's your cheat sheet. Okay, you can ignore the past 8 slides until you've got a problem if you just stick to this. This is not to get you to stop reading your documentation, but it's more, I figure you're all busy, and if you start out with a cheat sheet, that means you can implement this as soon as you go home and get around to everything else you want to do when you've got time. But this should give you some additional logging to go with the default logging. This just creates one log file called security and puts in the 6 different channels in the 6 different categories that are most important to be monitoring for security. If you get one of these things, it's often something that's going wrong. Insist, as an example, is internal consistency. They've cut it badly, but it's internal consistency. So if bind says that it just had an internal consistency problem, that often happens when you've got a buffer overflow or one of the many other types of vulnerabilities that you guys are going to spend this entire conference studying and possibly using. OS, anything to do with the OS, panic, anything really bad. Security, okay, that seemed like an important one. Xfer out, a lot of us like to watch who's doing zone transfers from us. So if you want to, you can send everything to Xfer out, you can watch Xfer out and filter for any servers that aren't your secondaries. If you see zone transfers that aren't your secondaries, that's probably bad. Update is something else to watch. That's for dynamic update. Okay, so let's get away from the boring stuff and the introductory stuff. Okay, what I want to do right now is actually turn ourselves over and take the role of the attacker. Okay, if I wanted to learn as much as I could, or if I wanted to take down your DNS server, what would I do against you? Because really, the best way I think that you can possibly make sure that you're secure enough. I won't say secure, but secure enough is to actually try to take some time, think like an attacker, and say, what could I get? Because you're not ever going to have perfect security. Your organization, you can't even get as close as you'd like to get probably, because your manager's going to say, listen, I only want you to spend the next 1.5 years securing our systems. I can't have you spend the next 4 years. Or at least that was probably what I got. So I think what you really want to do is take some time and attack your systems. And say this is what an attacker gets if they go after us, because that lets you sit down and actually prioritize and say, this is what I want to fix, and this is what I call acceptable risk. And if you talk to some of the military guys, a lot of them will get on what we've defined as acceptable risk and what we haven't, and the idea is to not make suppositions. You don't want to or assumptions. You don't want to make assumptions. You don't want to assume, yeah, there's a bunch of stuff that we're probably vulnerable on. You want to know what it is. So I'm going to give you the beginning of the attacks, and it'll be up to you to follow the industry and see where these things go. Okay, so DNS servers have traditionally made really great cracking targets for two very, very basic reasons. Bind keeps having security holes. It's the new send mail, right? Okay, it stinks. It's bad. Anybody here write bind? Okay, it stinks. It's bad. We don't really have a great substitute. Maybe DJBDNS will be that, but right now it's not widely deployed. So what we've all got is this thing that just is pretty god-awful because we keep finding new stuff. And it doesn't really matter what version you're running. You've got a better shot if you're running OpenBSD's bind 4 or whatever, but otherwise there are going to be vulnerabilities. So what we're going to do is talk about how you can kind of dodge some of those. Okay, so why else is bind a common target? It runs as root. Stuff that runs as root is really nice to go after because you don't have to worry about escalating privilege. You just crack that and now you've got root. Done. End of story. It runs as root. It's network accessible. Lots of people have to run it. That's a nice way in. That's a nice vector. Okay, so what are we going to do first? Let's just try to find out how much we can find out about the average target. And I've used two examples. One's the domain dumbtarget.j because well I figured nobody could sue me for using that one. And the other will be bastiolinux.org because again nobody can sue me for that one. Okay, if we start up NSLOOKUP, you can do this with dig, I know. If we start up NSLOOKUP, you can do this with Perl, I know. NSLOOKUP, set query, just tell it you want to see the name servers for a zone, and we ask what are the name servers for dumbtarget.j. And it comes back with, we've got two. We've got dumbtarget.j and ns2.dumbtarget.j. And we can find out, and so now we know which machine's the DNS servers. So we jot these down in our little form and say, okay, we know the DNS servers, let's find out what we can get out of them. Use this command. This is dig. NSLOOKUP can also do this, Perl can also do this. But all we're doing is we're just going to get a zone transfer. So we talk to the name server for dumbtarget.j, and we tell it to give us a zone transfer. AXFR stands for zone transfer. It's the command that's actually passed to get a zone transfer to DNS servers. And we're going to get a bunch of really useful information here. And I want you to not dismiss this. Look at everything. Look at the last 5 lines, the last 6 lines here, and then the next slide. To kind of look at what kind of information we're getting. Okay. we're getting IP addresses for machines. We're getting some interesting data like Pentium 133 and Red Hat 6.2. Okay, we're finding out what machine handles the mail. Thus, there's a send mail process running possibly. Thus, if there's a send mail exploit that we've got in our hands right now, we might be able to use to get root on another machine. Okay. We can look at some of the other machines. We should pay attention to the name, okay? We've got a machine called really dumb target J, okay? And it says, it claims that it's the admin's trusted workstation. It's an Athlon 850. It's running Red Hat 6.1. So this could be interesting. We've got rather dumb target and so on. We can look at all the puns. Okay, so first, what's your initial reaction? I mean, to those of you who already know about this, this is not a big deal. Yeah, in the back. Can I spoof the names of the machines that are in my DNS records? Yeah, we'll talk about it. The question was, can we hide some of this information that we just got out of that zone transfer? I'm going to teach you how to hide it. I'm going to teach you how to at least resist some of these simple attacks and really resist some of the more determined attackers to at least slow them down. Okay, so wait, we got two commands and we've got a full dump of their zone. Okay, this normally would have a lot more machines, but dumbtarget.j had to fit in 2 slides. Okay, so we also had a TXT record that we looked at. Okay, let's look at that. Admin's trusted workstation. Okay, gee, I wonder if that might be the sysadmin's workstation. I wonder if other machines will trust it. I wonder if it'll be like the past 3 environments that I've been in, where the admin's trusted workstation could run RSH commands to a bunch of machines to run backups. Yes, this does sound stupid. Yes, it's also commonly done. One of the things you people will definitely see both within and outside your organization is that when you go to audit it, a lot of the stuff that you thought was obvious, like don't use RSH, is actually not so obvious. Part of that's because sysadmins don't always know about security. Part of it's because they don't always have time to implement security. That don't always have time to is important. A lot of sysadmins have a huge list of things to do. Security is kind of at the bottom because if they don't get around to working on security, no one's really going to notice. Whereas if they don't get around to fixing the mail server, they'll have 53 users all yelling at them about how the mail server's not up. So we're going to see, the stuff that we're seeing here is going to be somewhat obvious, but it's also common. Okay, what else was in there? Okay, we saw hinfo records. Remember, we saw records that said the sysadmin's trusted box was running Red Hat 6.1. Okay, on this laptop here, personal stash, I keep a bunch of Red Hat 6.1 exploits. I mean, I have a bunch of Red Hat 6.0 exploits, 6.1, 6.2. It's all sorted by distribution and architecture. Okay, a lot of people who are compromising systems also have the same kind of toolkit, possibly on a CD-ROM. Okay, if I know the sysadmin's machine is a Red Hat 6.1 box, well, it might be patched, it might not, and I can just basically look through my directory and say, okay, which exploits do I have? I know I need to scan his machine and say, oh, so he's running sendmail, and I'll check sendmail, and I have an exploit against sendmail for Red Hat 6.1. Okay, he's going down. So this is, we don't want to be giving all this information away, and we are. Yeah. Okay, first, the question was, in my experience, how common is it for people to use hinfo? And I'll add TXT records in their zone data. 1, pretty uncommon. Large organizations tend to go for this. There's a reason for this. I was at a shop that only had, say, 200 machines, and one of the biggest problems actually was keeping inventory. What do we have? What OS versions are we running? Who's got what machines? And so they started using TXT, hinfo records to basically just keep track of inventory through DNS. Not many shops do this now. You definitely would like to know about it if your organization is doing it, something to check out. But let's say it's a minority now, but it's probably a dangerous minority. Yeah, question?
Just to follow that up, I mentioned my employer that I work for University, and the main campus DNS servers maintain that information. They are full of about 7 Class B networks. They maintain HINFO and
Okay, anybody, the follow-up comment was, gentleman here works for a university. Big Ten, he says, 7 Class B networks. That's a lot of machines. And they're using TXT and HInfo records to keep track of all their machines. So if you got all that, that'd be really useful. I know that when I get home, as a closet black hat, I'm going after this. What was that? Yeah, I'm going to go and check. I mean, there's 10. Okay, so I'm going to go home and check those 10. Thanks a lot. This gentleman here was socially engineered. Okay. Okay, so first, I don't really think I should be letting everyone do zone transfer. Okay, zone transfers are primarily because organizations tend to have more than one DNS server. What you do is you make one of your DNS servers a primary, and then you set up you set up 1 or 2 or 3 or 10 other DNS servers that can basically get copies of the complete zone data every so often and then distribute it. So now instead of everybody shooting their DNS requests at one machine and pounding that machine into oblivion, we can have it, we can pound on 2 or more machines. Okay, so zone transfers are mostly just to keep all of those duplicate machines, which we'll call secondary or slave servers, updated with the primary one. Okay, zone transfers were not meant for Jay to have his fun with redhat.com or whatever. I work for Mandrake. So we can use the allow transfer directive to try to block some of this off. Okay, and what I want to do is show you the named.conf file we were working on before, and we'll look at the allow transfer directive and adding that. Okay, so what I do first is we're just looking at italics. You see ACL secondaries. Okay, ACL, access control list. I want to define a group of machines, but I don't feel like continually copying the IP addresses throughout the file. So I'm just defining a macro called secondaries. And what I do, if you look down here, that main options block that we've got here, this options block, basically defines the defaults for our site, the defaults for this server. You generally want a default deny stance everywhere you can get it. In terms of security, okay? We want to say no one's allowed to do zone transfers whatsoever, okay? No one's allowed to do zone transfers. That's going to break something. So the next section of our file for our zone bestdeallinux.org, we say, okay, you can do zone transfers, but zone transfers can only be originated by our secondaries. So the bind server is going to say, okay, I'm going to block zone transfers from everyone, for every zone, except on bestdeallinux.org, I'm going to allow the secondaries to do zone transfers. Okay? And I'm going to do this for also the reverse section. The reverse section of bestdeallinux.org is that 192.168.1.foo, and we're going to allow transfers again just to the secondaries. Okay? And then you'll see on the local zone, this is just for the existing machine, so ain't nobody got to be able to do zone transfers from here, because it's just it's not necessary. We shouldn't have secondaries for the local host info. Okay. The nice thing is that what we just did was we blocked that zone transfer attack. Okay. We blocked it when someone doesn't take the time to spoof their IP address and find some way to get the replies. So for the bulk of attacks, we've just blocked somebody from doing zone transfers to get lots of data from us, which I'm really happy about. Okay, so there was something else we had set in here. Okay, we said, looking at the first slide, looking at the first page of this file, we have these allow query lines. Okay, and we say in general we're only going to allow queries against this server from internal hosts. Internals in ACL we define to be our internal IP space. Okay, and then for each zone we said, okay, if we're authoritative for bestdeallinux.org, that means we're giving out data on bestdeallinux.org to the whole world. So we better allow queries against that. So then we do this allow query any, which means only our internal nets are allowed to query us for anything. But if you're querying us specifically about bestdeallinux.org, you can be anybody in the world. Okay, if I just confused you, raise your hand. Cool. Okay. And we're doing the same thing on the other zones, specifically saying who's allowed to query. Again, default deny. You don't get nothing unless I already thought of you and decided you should get some data. Okay? Only give people what access they require. Okay? So we're setting a default deny on queries, and then we're saying who's allowed to actually query our servers. Now what about those allow recursion lines? Okay? So the thing with allow recursion is there's queries and then there's recursive queries. And the difference, if you remember that diagram we showed up earlier, was that normal queries, okay, a normal query, non-recursive, normal query asks you for one piece of information. Hey, can you tell me who's responsible for this subdomain? Hey, can you tell me what the address is for www.bastillelinux.org? Okay? A recursive query says, hi, I'm a resolver and I'm trying to find Yahoo, okay? And that one requires that my name server go and talk to the root servers, find out who's got yahoo.com, then talk to the name server for Yahoo and find out who's got www. And ask that server, and ask that server, what's the IP address for www.com? That's that, the 2-part or 3-part or 4-part query that's lots of work. That recursive query we should only be doing for our own internal hosts. Now, have I confused? Okay, cool. This is something that people get confused on very easily, in terms of recursive queries versus straight queries. I'm sorry? Okay. The question was, how do I define an internal host? And what I'm doing is I'm defining my internal hosts as those IP addresses I believe I own. This is not massively granular. It is also spoofable, but we're doing what we can. You can back a lot of this up with work on your firewall as well, but it's really smart to do it in at least in 2 or 3 ways. The important bit is that you're trying to do everything we're doing to secure a system in multiple ways because of a little principle we call defense in depth, which basically means protect something in as many ways as you can so that if one of the ways you're using fails, because the vendor announces a bug in it, or somebody finds some really smart guy at DEF CON or even Black Hat comes up with some way to compromise your method of defense, you're still not nailed. So you can do some of this through the firewall, but not all of it, depending on your firewall. Okay. So the other thing with the recursion lines is we can stop cache poisoning attacks. Okay, and we can even stop some of the DNS buffer overflows, because some of the attacks that we've got actually depend on an attacker being able to get our name server to query his name server for some information. Okay, now how do you do that? Well, you do what we did with NSLOOKUP. We point or dig. We point our resolver or whatever program we're using our resolver for. We point that at a given DNS server. Jay's DNS server. We point at Jay's DNS server and we say, by the way, do you have some information about hacksource.com? And I say, hacksource.com? I don't have anything about that. I go and ask the root servers, do you know anything about hacksource.com? And it says, go talk to this machine over here. And I go and talk to hacksource.com. My DNS server is now going to talk to hacksource.com. And hacksource.com delivers some nice little payload. And I'll bring up an attack where this is really useful. It delivers some nice little payload to either give us some bad data that we can serve to other people, or to root our machine, or at least take over the DNS server and possibly root the machine, or whatever. So one of the things we want to do is drop recursion just to avoid having our DNS server asking bad DNS servers or untrusted DNS servers for info. Not to completely avoid it, but to avoid an attacker making our DNS server do things like that. Okay. Yeah, in the back, there's a question. The question is to clarify recursive queries versus straight queries. And what I want to do, to the annoyance of the people watching this on video possibly, is basically take us back to this diagram. I've got a pointer. So there are 2 different ways, there are 2 different kinds of information you can query me for. on a bind server, okay, the resolver can ask me something about BastileLinux.org. And my DNS server will just go, since it's responsible for BastileLinux.org, and check its database, okay? And if that resolver, if it's an external resolver, if it's somebody who I don't have to give DNS services to, who all I've got to do is basically give the BastileLinux.org information to, and that's it, okay? That's a straight query. That's the allow query lines. On the other hand, okay, if there's a resolver that's asking me for www.math.umd.edu, okay, that's a recursive query because they ask for www.math.umd.edu. Okay, it's something I'm not responsible for. I don't have that information. So I've got to go talk to root servers. I've got to go talk to the University of Maryland. Okay, I've got to go then and talk to the math department's name server and get the data. That's not a single query. That's a recursive query. It means that my name server is sitting and doing all that work. Okay. Traditionally, if I'm an ISP, I've got to do that for everybody who comes looking. Okay. If I'm an ISP, I've got to do that for everybody I support. Okay. If I'm a university, I've got to do that for everybody on the university network. Those recursive queries. If you aren't somebody that I'm supposed to provide this service to, okay, if you're the rest of the world, then all I want to do is just do those straight queries. I just want to tell you about BastileLinux.org. I don't want to tell you about all the other domains because you should have your own ISP's DNS server, your own university's DNS server to make queries about math, about math.umd.edu or about / or whatever. Is that cleared up? Okay. So again, just to annoy the people who are watching this on video, we're going to jump back to the slide we were at. Okay. So the question is, are we safe from data mining yet? We just cut off those zone transfers. Okay, that's great. So someone can't do that attack anymore. They can't just ask us for a zone transfer and get tons and tons of data. Well, that's fine. But if they know about our hosts, if they know about which hosts we own, or they know how to make queries, they can even script this, but they can basically just make individual queries. Now what I'm doing is I'm firing dig at a particular name server. In this case, I'm using localhost just because I had to craft these slides myself. And I'm asking for an hinfo record for dum.target.j. Okay? So I'm asking for dum.target.j's hinfo record. And if we look at the answer, we get dum.target.j, penny 166, red hat 61. Okay, this is the same kind of information we're getting from the zone transfer. Now I've got to get it piece by piece. I have to target each machine and ask the DNS server, you have an hinfo record for this machine? Do you have a txt record for each machine? Okay. So somebody's going to ask, well, where do you get that list of machines? Well, I can sit there and I can say, it seems from looking at who is that J owns 192.168.1. everything. So I can go and ask it, okay, tell me about the machine 192.168.1.1. You have an hinfo record on that? What about .1.2? Do you have an hinfo record on that? And I can keep going and just get as much information as I want. And if I were a smart J, I'd probably sit down with Perl and take about 10 or 15 minutes and automate this. And somebody probably has. Or if they haven't, you probably will. But we're still giving away too much information. So what can we do? Yeah, we'll just stop giving away so much info. Okay? Stop using hinfo records. Where's the university guy? Let's pick on him. Okay. Let's stop using those hinfos. Let's go talk to our bosses instead and say, you want to maintain the inventory in another way. And they can laugh in our face, or they can tell us, oh, I didn't realize it was that dangerous. Okay? So when they say that, the first possibility is that they'll listen to us, and they say, okay, we'll remove all the hinfo and txts. We didn't realize it was quite so dangerous. Okay? And maybe they'll even listen to us when we say, could you not call the print spool machine print spool? Or as my friend Mike Rash, who's in this audience, has brought up, could we not make the firewall's name firewall? Yeah. So this is one of the things you can do. Okay. If your site is huge and needs to do this, or if your manager is particularly pointy-headed, You can go after other kinds of solutions. Bind 9 implements something called views, which are basically just Bind's way of trying to implement this other thing called split horizon DNS. And what you do, in essence, is you're going to maintain two different sets of DNS info. The set you give out to the whole world that says, this machine's my web server, this machine's my DNS server, you don't need to know about anything else. And then the set that we use in the rest of the university, which says, this is the machine that's running Red Hat 6.1, it's an Athlon 850, and so on. And hopefully, if we can segment, if we can split our DNS into two pieces, it's called split horizon or split brain, then we can actually stop outsiders, at least, possibly, from getting a lot of that info. No, it's not a perfect fix, but it takes us one step closer to the goal, okay? Okay, the question is, why should we even put all that information in DNS to begin with? I don't know, you know? I mean, you know, why are we still running Telnet? I don't know. I mean, you know, it's actually, I do know. The problem is that, first, there are lots of people who say, we still need this functionality until we can take the 4 days, 4 months to replace it, we're going to have to keep using it. Second, the alternative doesn't work for us. Third, security is not a real threat, right? So we'll just keep all that hinfo and txt records and we won't patch because no one's going to come after us because we're just a little university. And that's kind of why people do that stuff. It's they don't have time to fix it. They don't think they're going to get targeted. Oh, sorry. It's the first issue is it's extra work to put it in, but it's also extra work to not have it in some kind of centralized database. So everyone's made their own decisions, and all I can tell you guys is what I think the right decisions are, and how you can try to convince your managers or your underlings or whatever to do the right thing. Okay, we'll do what we can. So, but even with in terms of keeping a complete map, lots of people like to be able to say, okay, I don't have to tell all the users where the printer is. I just say, send all your printouts to printer.bestialinux.org. Okay, so calling it instead of printer, you know, whatever name, means now I have to do more work. So originally it was seen as doing less work because printer's just called printer. It's all good. It's a decision each person makes. Okay, nobody's got perfect security yet. They've had to balance that with their other goals. Okay, so split horizon DNS. We'll use two separate DNS servers. Okay, often we're going to use a firewall or packet filter to separate them. They can be on the same machine. They don't have to be on separate machines. We've just got to have something that actually sends some of the traffic to one DNS server and some of the traffic to another. You can do this manually, but it can be a pain. Now, possibly you run them both on the same machine, and you tell the machine forward all the external requests in to this DNS server and forward the internal requests into this other DNS server, running on two separate ports. Okay, you can do this. Possibly that same machine they're both sitting on might be the firewall. Lots of really small sites do that. Okay, the idea behind the internal DNS server. Okay, it only accepts requests from internal hosts. Internal only. You enforce this via the firewall, and you enforce this via your named.conf file. Okay, you've got to do it both ways. Again, defense in depth. The next thing is it's got all the information you want to put in it. Not all the information that you could put in it, but all the information you decided you need internally. Okay, and that's a personal decision. Okay, it's going to forward all you're going to forward all requests for external data to the external DNS server. Okay, and there are directives to do this. You can put in the configuration file, or you can do this with the packet filter itself. And then you won't allow zone transfers off this internal machine unless you've got other internal secondaries. And then you only allow zone transfers from the internal secondaries. You're very careful about that, and you again enforce this with the firewall. Your external DNS server, on the other hand, okay, the external DNS server should be doing recursion for your internal hosts. Okay, that means when your internal host asks for /.org, okay, the external DNS server, the one that we've really got to worry about, gets all the /.org recursion. It has to do all that extra work of talking to the root servers and talking to name servers you don't trust. The idea is that you try to insulate your internal DNS server from either talking to external DNS servers or talking to external clients. That way we give the attacker very few ways to actually get at our DNS server, at our internal one. Okay, we've still got to have that external one, right? Okay, so the external one's the one we're going to put all our risk on. It's going to have a much sparser zone database. It'll know about the web server, it'll know about the mail servers, but it's not going to know about a whole bunch else. Okay. Also, we can look at doing something like we can do network address translation where all of our clients seem to come from a single IP address. And the name for that IP address might be client.bastillelinux.org instead of, admin, or whatever you guys are using for your names. Okay. And we'll allow zone transfers from this host, from the external DNS server, to the other secondary servers, because, the names must go on. Okay. So let's look at, we've talked about data mining some, so let's look at what we can do to crack the DNS server. Okay, bind 8.2.0, bind 8.2.1 was vulnerable to remote root exploit. This was not good, because a whole lot of systems were vulnerable, and it was really bad, and a lot of us found out about vulnerable name servers when this happened. Okay. The thing is, you had lots of exploitable systems, because Red Hat 6.0, among lots of other distributions, were shipping with this by default, and lots of people don't patch their systems, so lots of people got nailed. There are a couple worms that just basically sit there and go after a name server, get root on a machine, and propagate. Okay, there's your tutorial. I'm not going to walk through this attack because we really don't have time. If you guys beg me, I'd be happy during a BOF or a break to actually illustrate the attack on a laptop with a VMware machine. But you can just hit this website, www.hack.co.za, and that has two files: the how-to, which was partly responsible for making it so damn easy to use the exploit, and then the exploit itself, which is T66C. I checked this morning before I got on my plane. Both of those files are there. They're easy to find. Go get them and root your favorite. Test your machines. Okay. So now suppose you've got your exploit. You know how to use it. You've tested it on the system. You know it works against your Red Hat system. How do you find machines? Well, the thing is, the way script kiddies tend to work is not that they generally target you. They generally go looking for vulnerable systems. Because script kiddies' MO tends to be something along the lines of find an exploit site, download 5 exploits. Hopefully one of them works for you. Now that you find the one that works, scan large portions of the internet for machines that are actually vulnerable to this. Take those machines and use them for whatever you want. Porn sites, wares sites, DDoS, something to add to your DDoS army, whatever it is you want to do with rooted boxes. Okay? So if you wanted to find out if a machine was vulnerable, the great thing about bind is, you just ask bind, what version are you? If it's 8.2.0 or 8.2.1, nail it. Okay? So this dig command is the canonical one we all use. Supplement your URNS for those two URNSs, and it'll tell you what version of bind you've got. Here's the output on my system in red. Okay, 8.2.2. Okay, that wasn't vulnerable to that exploit, but it was vulnerable to others. Okay, so everyone's going to go after me when they get home. I've taken that machine down. Okay, so we can look at actually changing that output. We don't have to say 8.2.0 anymore. A bunch of you will all of a sudden stand up screaming on your chairs, on the tables. You're going to make them collapse. You're going to fall down. You're going to sue me because I put up this slide. But you're going to scream, security through obscurity is bad. Well, yeah, obscurity can be really, really useful. It'd be nice to not tell the attackers what version of bind we're running. It's not that we're going to use that as our only defense, but it sure as hell, slows some people down and possibly stops some people from ever coming after us. Okay, it may not defend against their attack, but maybe 90% of the people who would have come after us don't come after us anymore because they think we're not running the version of bind that they're looking for. It's a Jedi mind trick. Okay, so basically it's very easy to do this. In the options section, we write version and whatever we wanted to kick out. Any string you want. Doesn't have to be digits. I'd go for digits. Okay, I used go away here. You can use anything you want. I'd try to blend in. If somebody's searching for 8.2.2, then if you've got go away, you probably don't match. But go for 9.0. Go for 4.9.7, since that seems to be relatively safe to the stuff that's hitting 8.2.2. I would just pick something. This is not a complete protection, but it does save you against a lot of the script kiddies who are basically going and scanning large portions of the internet looking for somebody that's vulnerable. Okay? There are other defenses. Okay? There's actually defenses against the attack, or more to the point, we're going to try to contain the attack. Right now, what we've talked about so far, when we tried to limit everybody's access to our DNS server, was we tried to give an attacker who was firing off that attack less ability to get to our DNS servers or to get our DNS servers to do things that we don't want it to do for them. Okay? The particular attack for 820.821 depends on you being able to, on an attacker being able to get my DNS server, the target DNS server, to query his machine. If he can't get that to happen, the attack fails right there, and the bulk of the script keys will just go away. A really, really good attacker, who we're luckily in the minority, will probably try to find some other kind of access. They might spoof their IP address. They might actually just try to come from some machine inside your domain. But well, I'll give you as much as I can, right? Okay. So what do we do when they actually got access? When they had enough access to launch their attack, and we just want to contain a successful one. Okay. The first thing is, don't be vulnerable. Okay? Patch your machines. I'm not saying patch your machines because I want to be annoying. I'm saying patch your machines because like at least 10% of this room doesn't have their machines fully patched. Who's patched in the last 2 months? Raise your hand. Okay. For people who are watching this on video, there are a significant number of hands that did not go up. How about in the last 6 months? Raise your hand if you patched in the last 6. Okay, so for those watching this on video, it was significantly less than 10% of the room. Let's just say there are not a lot of people patching. So patch your systems, don't be vulnerable. I promised you there were 2 really boring areas of security. 1 was logging, 2 is patching. Okay, what else can we do? Well, we had a remote root hole, so we can remove we can't remove the remote part. DNS is available to everybody basically, but we can remove the root part. Okay, if you run DNS as a non-root user, like user DNS, then they don't get user root when they break in when they get this system to give them a shell. Instead of getting a root shell, they get a shell with user DNS, who hopefully won't have a whole lot of access on your system. Okay, and I've given you instructions for how you can do this pretty easily. All you do is create a DNS user, create a DNS group, and modify your init scripts to actually tell the DNS server to drop privileges from root down to user DNS. Warning, don't use user nobody. Don't use any of the users that's already on your system. If you use user nobody for DNS, and user nobody is also being used to like own all the CGI scripts or something, then you've got a problem because you just gave somebody gets user nobody. They use user nobody to modify the CGI scripts, and now they're on your system with whatever user the web was, and then they continue. You know, we've got this privilege escalation problem. So use distinct users for each server. I like DNS. So we don't have, our attacker at this point, if our attacker fires the exploit, the attacker doesn't get root anymore. Okay. This also is not really great if the attacker was a worm. The worm is not really happy anymore. It's coming against the system and not getting what it expected, and worms are pretty stupid usually, so you just save yourself from a worm and a whole bunch of other attackers. Okay. Your attacker, if they're bright, can still probably try to escalate privilege. Okay? That means that they'll get user DNS, and now they'll find something else that's vulnerable in the system that could only get attacked through a local hole. They'll exploit the local hole to get root. Okay? So we want to try to block this, but this is a whole other talk or an article which I've given you a link to on a set UID audit. You can audit your system, try to find everything that's running as root that user DNS could exploit, and try to strip privilege away from it. You know, make sure that there are fewer ways to get from user DNS to user root. There's another cool thing we can do through the DNS server itself, and that's we can chroot it. And chroot it, for those of you who haven't played with this before, basically says that instead of the user DNS being able to walk around the file system and read anything that's world readable, they can only read this small little directory we stuck them in that we've carefully constructed. Okay? And if they can only read that, their attack doesn't get them very far. Because now they're on the system with user DNS, they can't really do much, they can't get much information, they're pretty much stymied, which is absolutely wonderful. And what I've given you is, again, cheat sheets that you won't use till you get home on how to chroot bind under Solaris. Okay? And this is a full 6 slides. It basically means you create a directory called chroot named D, you stick everything in it that named D needs, and then you start named out of there. And that includes copying over the libraries. And basically this technique can be used for other systems, or you can do what a lot of people do, which is look for my paper or other people's papers on this and copy. So the same exploration of how to chroot something doesn't have to be done multiple times. Okay. If we run named chrooted, we've locked them into this directory called chroot named, which again, for this particular attack, and basically all the DNS attacks that I've seen that are trying to for remote root, gives an attacker basically nada, zilch, nothing. I mean, they're on, but they can't really do anything. So what was the point, So it's pretty cool. Okay, you'll have to change your init script to actually start your DNS server this way. But once you've done this, it's pretty maintenance free. Okay, so what else would you do at this point? Unbind. I'd go for split horizon because I like it, because you can cut the amount of data you have. You can cut the attack vector on your internal DNS servers. You can stop giving away so much information. Split horizon is cool, and I gave you guys some work on how to do this. The next thing you can really do is basically just go read the book. This is, again, what a lot of people will be like, wait a second, I came to your talk for this. Yeah, the talk gives you everything that I can do, that I can give you right now, but the best way to really secure a system is to understand it as thoroughly as possible. So when something weird is going on, you understand if this is abnormal or normal. And you also you might understand the attack itself if you're watching a new attack we've never seen before. Okay. I've also thrown in a few slides about DJBDNS, and I'm promising you guys an article. If you look on my website, I'm going to put up some extra slides and an article specifically on DJBDNS. The problem with DJBDNS is it's definitely not for the timid. You should really understand your bind servers and DNS in general before you try to run it. Basically, it's a whole lot safer than bind because they've taken all the pieces. And instead of having this really big complex system running as root, which is bind, you get a bunch of little pieces that all run with only the level of privilege they require, and they're pretty detached from each other, so they only communicate what they need to. The nice thing is that you've actually got the part of the system that's vulnerable when there is a vulnerability released. In bind, that part of the system will have full ability to communicate with the rest of the system to get it to do weird things. In this case, with DJBDNS, since it's separated into pieces, the part that's vulnerable may have no ability to pass data or pass data without filtering to the parts that actually can do whatever the attacker wants, which means that you can be a whole lot safer with this stuff. This is the same MO as replacing sendmail with postfix. Okay, and I really like that a lot as well. The problem is it's really pretty difficult to administer. You have to really learn a lot. Basically, DJBDNS is broken up into a few pieces. One is called DNS cache, which just does the recursive query part. Okay, instead of having one big server that does it all, you've got DNS cache that does all the recursive queries. You've got tiny DNS that actually does the stuff that's specific to your domain, okay, and only requests specific to your domain. So tiny DNS is the stuff that is the one that the world is talking to. The world needs to all know about bestialinux.org, okay? And your internal clients only talk to DNS cache, okay? So they break up the functionality and get a whole lot of security out of that. We also separate the part of the system that does the zone transfers into a separate daemon. And again, this gives us a whole lot more granularity of control and also an ability to try to make it a whole lot tougher for someone to exploit this system if there's a bug. Coercion.org, which is normally really great for reading debates and stuff, actually has a great article on how to set up DJBDNS in like 10 minutes. Maintaining it's a different story, but this will help you set it up. The nice thing is a lot of what we've done here is a lot easier to do with DJBDNS. All the servers run non-root as default. Okay, all of them run chrooted by default. We don't have to do anything weird there. They haven't had a security hole yet, and they're promising what is now a smaller sum of money, but still promising a prize to anybody who can come up with a hole. Prize has gone uncollected. Prize has not gone uncollected if they'd offered one for bind, which has had, oh God knows how many problems. Okay? There's also some cool stuff like if you don't want a NAT and you want to make all your machines, if you don't want to give out internal data, if you're like this gentleman over here who said, why are we giving out all this internal data? You set up WAL DNS, and WAL DNS basically says, okay, you want to know what the IP, what the name is for 1.2.3.4? It's 1.2.3.4 in essence. And again, we're restricting data. Okay? Because we're separating out data, we can stop people from doing queries we don't want to do queries. And it's really easy to go split horizon this way. So should you use it? Okay? It's got a much better security history than bind. It's got a much better architecture. Selling your boss on the switch will be difficult. Heck, selling yourself on the switch will be difficult because of the work involved. It's relatively easy to set up split horizon, but it's also relatively difficult to configure. But I sure as heck like it, and I'll give you guys some more information on my website, I promise. Okay, so go learn more about this because DNS is one hell of a problem. I mean, you know, if your DNS server gets taken over, your clients are really nailed. Okay, so go in peace, sin no more. Update your DNS servers. Either run DJB or make your bind into a much better configured machine. And that's it. Check out my website for more info.